Well, good afternoon, everybody. Thank you for making the time to come in and listen to another seminar. I hope you're enjoying the day. I know that there's a lot of interest and activity going on in the halls outside. A lot of people are finding out about things, and that's really good news. My name is Richard Flanders. I look after the cloud business for Checkpoint in the UK. If you're not familiar with Checkpoint, we are one of the largest cybersecurity companies in the world. We're based in Israel, and we've been providing security solutions to the world for the last 25 years or so. But today, I'm going to talk about something which, to Checkpoint and to most of us, is relatively new, and that's security in the cloud. And frankly, I don't envy the CISO currently. The situation in terms of security within the cloud is very, very difficult to pin down. There are lots of organizations who have suffered hugely from data loss, from information being published publicly, which shouldn't have been, with leaks, with compromises within their organizations. And this is happening all the time. It's not just happening here and there. There are lots and lots and lots of instances where data has been lost, has been compromised, fundamentally because not enough consideration has been made towards how that data is secured within both public and private environments. And Checkpoint, having traditionally been in the business of firewalling and all those good things, gateways, we turned our minds to this about 4 or 5 years ago and realized that what the market needed was solutions which could be deployed in private and public cloud with as much ease and with as much impact as it was possible to do within the private infrastructure space. And that led us to look at the different models of architecture that organizations were using and are using within their cloud deployments. Traditionally, you might deploy a VPC within the cloud to protect your data, virtual private cloud. That's all well and good, a very well-known methodology, very well-known architecture. But we also have to deal with things like containers, whereby individual applications within the cloud are not talking to each other via the network or any networking functionality. They're talking to each other at the kernel level. And that makes it extremely difficult for us to identify potential threats existing between those applications. And of course, we also have to contend now with serverless operation, whereby a Lambda function within the cloud is spinning up an instance very rapidly. That instance is doing what it needs to do, and then it's being spun down and no longer exists. Now, we have to have a technology which is able to understand these functions and be able to apply airtight security right across the whole spectrum, from public to private cloud. And traditionally, everything within that cloud space is provided as a service, the load balancers, data and databases, file systems, all of those good things, all provided as a service. And the very nature of the cloud itself is elastic and ephemeral. It's changing all the time. It's a very dynamic environment. Trying to deploy and impose a traditional security structure on that cloud space is almost impossible. It simply doesn't work. And the fact that many, many businesses are using a multi-cloud approach, in other words, they're using private cloud, they're using public cloud, they're using many flavors of public cloud, makes the whole picture more complex, more difficult to deal with. I'd urge you to watch this video, which is called "The Perimeter is Dead, Long Live the Perimeter," and it outlines the fact that there is still a requirement to protect the perimeter and the internal operation of cloud right now. That requirement has not gone away. So do have a look at that video, it's on YouTube. But the key security challenges remain these. First and foremost, cloud environments are dynamic. Cloud security should prevent fatal misconfigurations and enforce a strict security posture within that cloud. Cloud security should actively protect workloads and cloud services from modern attacks. And let me tell you, these attacks are evolving at a staggering rate. It's frightening. We have a threat cloud within Checkpoint that's growing on a daily basis in terms of the number of threats that are being input to that cloud, and that cloud interpreting that activity within our customers' cloud deployments. And thirdly, security shouldn't slow down cloud innovation. The very reason most organizations go into cloud is to be agile. It's not to save money necessarily. It's to be agile. It's to be able to shorten time to market. It's to be able to react to what the competition is doing. So we believe that cloud security should address all of those challenges. And we have indeed a number of solutions under the overall CloudGuard branding banner, which enable customers to deploy all the classic security technology that we've been working on for the last 25 years within a virtualized cloud environment. So, for example, we have CloudGuard IaaS on this slide, which deploys virtualized gateways between virtual machines within a cloud environment, and on those virtual gateways is deployed all the software that we would traditionally find in a hardware-software appliance. So intrusion protection, data loss prevention, antivirus, all those good things included in a virtualized gateway that it's possible to deploy into both public and private cloud and act as a security measure to prevent the proliferation of malware from one virtual machine to another. We call this CloudGuard IaaS, and it's applicable in the public cloud space via Amazon Web Services, via Azure, GCP, all those well-known public cloud platforms. But also, it can run in a private cloud environment predicated on some kind of software-defined network, like VMware's NSX or Cisco's ACI. And this technology is what we call adaptive security. It will adapt its posture according to the changes that are made by, in this instance, the software-defined networking technology you see on the screen there within the private cloud. And it does the same within the public cloud. That public cloud is not, as far as security is concerned, predicated on an SDN, because those public cloud providers don't expose their SDN to us. However, we can deploy virtualized gateways within that public cloud environment to protect against proliferation of malware in exactly the same way as we can in the private cloud. So that's all well and good. And these solutions work. They are deployed in 6,000 to 7,000 customers now globally, and they're being used to great effect to combat the sort of threat vectors that we're seeing. However, we identified quite recently that there's perhaps a gap in terms of the visibility you have as users into your security posture within the cloud, your compliance posture, and also how you're controlling who has access to that cloud deployment. So, back in November, Checkpoint completed an acquisition of a company called Dome9. Dome9 was formed back in 2011, and was specifically targeted at providing security for public cloud native controls. So that's AWS, Microsoft Azure, and Google Cloud Platform. It only works within the public cloud. And Dome9 spent a lot of time reviewing what was available on the market and how we could offer customers, or how they could offer customers, much more direct visibility, what was happening within their cloud deployment, how it was adhering to, or otherwise, to different standards, and how access control could be applied to that cloud deployment. So 4 pillars, essentially, to this solution. Firstly, network security. Where do the different elements within my infrastructure sit with regard to their security posture? What are their particular aspects which are affecting the security of the data held within that element? Secondarily, continuous compliance, the ability to be able to measure your cloud deployment against particular standards, be they ISO, be they PCC, be they GDPR, which is obviously the most popular one, against HIPAA, against a whole range of different standards. How protected is my data against that particular standard? And how do I remediate the deployment in order to make it more compliant? Thirdly, PIP, Privileged Identity Protection. In other words, who has access to a particular cloud deployment? How long do they have access to it? And which bit of the cloud deployment do they actually have access to? Which servers within it, which elements, which storage, which databases, etc. So controlling that is clearly a big element of how you secure your cloud deployment. And finally, cloud threat intelligence. In other words, a big mind that understands exactly what threatening behavior looks like within the cloud, how to effectively change your configuration so it's no longer vulnerable to that particular threat vector. So these are the four pillars of the Dome 9 solution, and we're integrating that very rapidly into the Checkpoint portfolio. It is currently a standalone product and can be deployed wherever. You don't have to have Checkpoint technology at all, but what it does do is it provides you with an enormous amount of visibility and control over the way you configure your security within the cloud. So, of those four pillars, complete visibility at a network level, and I'll go into a little bit more detail around this diagram in a second. Complete visibility at the network level. Continuous compliance, being able to measure your deployment against whichever standard you choose, or indeed being able to write your own data standards and apply them and measure yourself against your own standard. Prevention and remediation. So many of the errors that we see within the cloud are brought about, or successful attacks, should I say, are brought about by people making errors in configuration. Dome 9 will go out and it will check via cloud bots, it will check whether or not the configuration you've set up within your cloud deployment is potentially at risk because of a mistake in configuration that you might have made. And lastly, cloud security intelligence, the ability to spot what bad looks like, incoming, so to speak, and say, you've got a potential problem here, this is how you can address it, do you want me to do this automatically, or do you want to do it yourself, administrator? Okay. So a little bit more detail. Around the complete visibility piece, you'll see here a schema, a very graphic demonstration of different elements within the cloud infrastructure. And these elements are usually virtual machines or databases or whatever, servers. You click on them, and at the side here, you'll see, the right-hand side of the slide, a list of information pertaining to that particular element. In this instance, it's a database server. Sorry, it's not very readable from the back. But this is a database server. You can click on that, and it will give you the information that appears on the right-hand side of the screen, and it will enable you, if you have the correct permissions, it will enable you to make changes to move that element from one particular zone to another zone within the security schema. So you'll notice along the top, we have elements which are web-facing, which are not protected in that sense and are vulnerable to attack from outside. We go through a DMZ, a partially open, effectively internal, and fully internal zone. And what we find is, when this is spun up in an environment, a lot of people will look at it and say, I didn't realize that that database server, which I thought was sitting in the internal zone, actually it transpires, because of the network routing, that it's finished up in the DMZ. And I don't want it there, because it's vulnerable to attack. Now, underneath, you'll see as well a list of different actions you can take to remediate any problems that this schematic is showing you. So it gives you control over where you place the elements within the infrastructure according to their security vulnerability. So in summary, automatic discovery and classification of security groups by exposure level. How exposed are you in this particular space? Intuitive visualization of the topology, object-based IP management with IP lists, VPC flow log overlay, in other words, virtual private cloud logs, what's sitting where within the environment, and the traffic analysis between those elements, and most importantly, click-through remediation. So clicking on the element and being able to remediate any existing problems that this is showing up. So that's pillar one of the solution. Secondarily, compliance. You're seeking to be compliant, in a lot of instances, with a lot of different data standards. They could be, well, mostly GDPR, but also PCI, DSS, HIPAA, ISO 27001. In this instance, what you see on here is the results of a compliance check against, top right, the middle of the slide, AWS CIS Foundations version 1.1, 1.1.0. And what this is showing us is how compliant was I, my cloud deployment, at this particular point in time when this cloud assessment was run. And what we can see is, unfortunately, it wasn't particularly compliant with AWS CIS Foundations 1.1.0. In fact, 88% of the elements within the infrastructure failed the test. Well, that's interesting to know, and also interesting to know if, for example, you're running a GDPR check or you're running a PCC check and you want to see graphically how well you are conforming to that standard. But not only that, it gives you the opportunity down at the bottom, via this results table, to take action to remediate the issues that are causing you to be non-compliant in the first place. So you can click on this table at the bottom. It will show you what is tested, what is non-compliant, why it's non-compliant, and what you need to do to rectify that situation. Now, you can run this on an hourly basis if you wish, or every day, or every week, and you can run it back 6 months previously and say, what was our security posture back then when we first ran it? What is it now? And how has that contributed to us being more compliant with a particular standard? Furthermore, you can write within this tool via what's called GSL, Governance Specification Language. In very basic English, you can write your own data rules. So if you have a particular in-house standard that you have to adhere to, and it has to be checked on a regular basis, then you can input that rule set into the tool, which will then measure your cloud deployment against that rule set and deliver exactly this report to tell you whether or not you're adhering to it. Also useful if the auditors happen to drop in and say, can we check your compliance level against PCI? Then with this tool, yes, you can instantly. Take a lot of professional services resource to gather this kind of information using current tools to present it in this form in such a rapid way. This takes about 30 seconds to run as a report within an average size deployment. So very, very useful. Thousands of different security checks, and bearing in mind, of course, that Dome 9 is delivered as a SaaS solution. In other words, you don't have to deploy anything on site, you don't have to deploy any agents. Basically, it's delivered as a service, and at the back end of that service are thousands of security checks, multiple compliance standards like PCI, like CIS benchmarks, et cetera, continuous compliance, granular assessments, driving deep, deep into the infrastructure to say, how compliant am I? A compliance posture history. Where was I at a particular point when that data went missing? How adherent was I to ISO 27000? We can tell with this tool. Extensive entity and service coverage right across all the main flavors of cloud, AWS, Azure, and GCP. And printable reports. You can output this information to a printable format, which is easy to distribute and show to people if they require it. In terms of taking that compliance thing a little bit further, we can automate the compliance procedure by kicking off this compliance check here on the left-hand side of the slide. Following the path through, it produces a report, which you've seen already, which tells you how compliant you are, and it will output that data into a DO9 scheduled compliance summary report. In other words, how compliant are we? Let's feed that information then to something like Jira or ServiceNow or whatever overall management tool you happen to be using. It can output that data to those tools. That data can be read, and then that automated compliance process is complete. And you have two options. It will say to you, do you want me to auto-remediate the problems that you might have? Say, for example, you left a S3 bucket open in AWS. Do you have a rule that says, if you come across that, CloudBots, can you close it down for me? Or you can have it alert you and say, well, you've got a problem over here. Do you want to fix it? If so, these are the steps you need to take. So effectively two options. I referred to the governance and compliance language, GSL, governance specification language. As you can see, there's some examples here where there are packaged versions of the rule sets that you can use, which are easy and straightforward to deploy, or you can use GSL to write your own. There's even a drag and drop, which I don't have a slide of, but there's even a drag and drop menu which allows you to pull different rules into the rule set without having to type anything into GSL. So in terms of being flexible about what standards you apply to your data, what security standards overall, be they public standards or your own, then this is ultimately flexible in giving you the ability to do that. The fact is that analysing the traffic that AWS or Google or whatever spits out is actually really hard. It's harder than you think, because unless you understand that or a code coming out of the cloud that says it's a VPC Flowlog version 2, that's the AWS account number, etc., unless you have a tool that understands all that, you've got very little chance of picking up potential threats that come about through something like a Lambda function that's spun up within AWS, and it's talking to some kind of known malicious destination. So in this instance, the AWS has spun up as a serverless computing element. It's spun up the Lambda function spun something up, and it's talking to a known malicious destination. That IP address there, 178.137, etc., is a known a malicious address. So it's sending outbound traffic over port 80 to a malicious IP address. It's causing you a problem. Now, that Lambda function might only spin up for a matter of minutes or even seconds. But the fact is, it will exfiltrate data from your infrastructure before you've realized it. Unless you have a tool that can read that code very quickly and say, wait a minute, you've got a problem here. I know through my threat cloud intelligence that that is a malicious address. I know to block that, to stop that happening. Now, it reacts very, very quickly. It would be almost impossible to do that without the assistance of some kind of automated tool. So, looking at the overall picture, from a threat defense perspective within the cloud, if you're looking at an attack that's at the surface of the network, then we would deploy CloudGuard IaaS, Infrastructure as a Service tool, and we will deploy DO9 as a joint approach to securing that particular surface of attack. From an identity perspective, we deploy DO9 IAM safety, Identity Access Management. If I'm an administrator, I'm administrating a bit of the cloud, and I need access for 5 developers to that piece of cloud so they can use it, they can develop their code, and do what they need to do. It's very hard with using native tools within AWS or Azure to say, I'd like to give person X a week of access time to that particular portion of cloud, and at the end of all that, shut that access down and don't allow them to attach to that anymore. Quite difficult to do that within the current controls. With this tool, very easy. You can even do it from a mobile phone. So if you're the admin, you type in whoever you want that developer to be, with their credentials, they will then be able to access parts of the cloud that you specify for a length of time that you specify. So the danger of leaving accesses open to individuals after they've completed what they need to complete is eradicated. If you're looking at attacks from the control plane perspective, then DOM 9 will provide you with the compliance that we've talked to, or the analysis of compliance that we spoke about, and the ability to remediate potential problems in the way that your cloud deployment is configured. If you're asking yourselves the question, so where do these two solutions come together? And clearly over time, Checkpoint will be looking to effectively blend these two solutions together under one umbrella. If you look at it currently from an infrastructure as a service perspective, we're offering market-leading threat prevention, anti-bots, IPS, anti-malware, all those good things, in a deployable virtualized gateway that can securely connect to your hybrid cloud, be that private or public, and is adaptive policy. In other words, it changes to suit the changes that are being made within the cloud. On the other side of the fence now with DOM 9, we've added to our abilities by giving you full security and visibility and control over what you have in the cloud, giving you the opportunity to protect cloud services and applications so they're not exposed, continuous compliance for cloud-native services, auto-remediation of security misconfigurations, who's made a mistake, how can we fix it, and active protection against identity theft and data loss. So in terms of having an overall strategy for protecting your data in the cloud, it is now as strong as it ever was in terms of the technology that you provide, you're addressing it with. In terms of customers, you'll see there's a huge customer roster. Admittedly, there is at the moment a bias towards the financial side of things. That's principally because the compliance engine is so powerful within this tool. It's encouraged a lot of financial institutions to go down that route and say we absolutely need to understand how compliant we are in different areas. So they've adopted this very, very quickly. But that customer list is growing all the time. Bear in mind, we only acquired this company back in November. So now that it's part of Checkpoint, all that extra R&D development and effort going on behind the scenes will speed up very dramatically. So to summarize our cloud security offerings in 2019, we have a solution to protect enterprise data, preventing targeted attacks on SaaS applications, Office 365, Salesforce, whatever you happen to be using. We've got IaaS, protecting public and private cloud networks with advanced threat prevention, using all the intelligence and technology that we've built over the last 25 years, pushing it into a virtualized gateway and allowing you to deploy it within your cloud network. And finally, DOM 9, protecting against cloud configuration mistakes, identity theft, and data loss. Full visibility and control of your network security, posture, and the best-in-class governance and effectively compliance-driven behavior. This is quite a useful slide. I know these slides will be distributed afterwards, but this shows you in, I'm afraid it's probably not particularly readable from the back, but it will show you exactly where the different aspects of cloud security fall into the different solutions that we have. We have a stand here, and we will be around all of the afternoon. We're working in conjunction with our partner Sapphire, so do come, find the Checkpoint banners, and we'd be happy to talk to you about what we can offer you in terms of protection in the cloud. Thank you very much for your time. Appreciate it.